Okay, welcome back. So as promised, we're going to start with the building of the Border Gateway Protocol inside of our service provider cloud. This will be used to essentially transport customer routes from Cisco Site A over to Cisco Site B and vice versa. And like I had said earlier, you can have multiple customers hanging off the same provider edge router. They can use the same IP scheme. They won't interfere with one another. So it's a pretty powerful config at the end of the day, and there's a reason service providers use it, and there's a reason it's still out there. It's tried and true. So let's get right into it here. So we're going to start on router 1. So we're going to define our BGP process, if you will. So we're going to say router BGP 7029. Okay, so that turns on BGP. And with BGP, well, the way we're going to do it is we're going to define our neighbors. Okay, we're going to dictate who we're trying to peer with, as opposed to trying to do anything automatic or listen for BGP peerings. So we're going to say neighbor, and we're going to use all loopbacks here. Okay, so we're going to neighbor up with router 2. So we're going to do neighbor 10.2.2.2. We're going to tell it his remote AS is 7029, so it's IBGP, okay? And then we're going to do neighbor 10.2.2.2. We're going to activate him, which basically activates the IPv4 address family within BGP, okay? And we are going to come over to router 2. I'll go back and forth between these routers a bunch of times. I'm trying to take baby steps to demonstrate things, so bear with me as I kind of go back and forth. And I'll probably fumble through this a little bit because, again, I'm a little rusty. I haven't done this specific config in quite a while. So router 2, we're going to config the router process 7029. We're going to say neighbor 10.1.1.1 because router 1, his remote AS is 7029. And we're going to go ahead and we're going to activate him as well. We're going to say neighbor 10.3.3.3. His remote AS is, again, 7029. And we're going to activate him as well. Okay. So if we look at the config as it stands right now, we've got 2 neighbors with their remote AS, and then we've activated the IPv4 family, and we've activated those routers. Okay. Let's just go over to router 3 real quick. Just get his basic neighbor ships on there. Neighbor 10.2.2.2. Remote AS is 7029. Activate. Okay. So what we should. Oh, I'm sorry. I left off a command. I'm sorry. I told you I'd fumble through this. So we have to, since this is IBGP doesn't have to be directly connected with the neighbors, or their neighbors don't have to be directly connected, which we'll see when we do the VPN v4 peering between 1 and 3. Obviously, they're a hop away from one another, but we have to, since we're using the loopback to peer, we have to tell it we're going to use our loopback as a source to peer with that router. So on router 1, what we need to do is we have to say under router BGP, we're going to say neighbor 10.2.2.2, and we're going to say the update source is our loopback 0. Okay, we need to do that on all the boxes. All right, so alright, and then last but not least, router 3. Okay, so I'm not going to end out, I'll stay there. So show IP-BGP summary. Okay, so once we do, so let's look at the config real quick. Pretty basic, just turning on the BGP process, and we're telling it about one single neighbor at the moment, which is IBGP because it's the same ASN. And we're telling it that the update source is our loopback address, okay? And the verification is show IP BGP summary, okay? So this is a great command to run to verify if your neighbor is up, down, or in some other state, okay? So what you're looking for is the neighbor. This is the version of BGP. This is the autonomous system number. You see some of the sent receive messages. You're looking for the up down. So we see that at this point in time it was up for 50 seconds. And this column here is what we're learning. How many prefixes are we learning from that neighbor? In this case, we're not learning anything yet. We haven't advertised. We haven't done any of that yet. We're simply just peering with the neighbor. Okay, so if we ran that command on all the boxes, basically router 1's got its neighbor. Router 2 has 1 and 3, and router 3 has 2. Okay, so what we need to do next is we need to do the VPN v4 peering, and we have to introduce the route reflection piece of this as well. Okay, so let's go back into BGP, and we're gonna say neighbor 10.222 under the address family IPv4. We're going to tell it that this needs to be done on router 2. My apologies. IPv4. We're going to tell router 2 that neighbor 10.111 is a route reflector client. Okay? We're going to tell it that 10.333 is a route reflector client. Okay? So you only have to do that on the route reflector. Like we said, router 2 is the route reflector, 1 and 3 are the clients. Okay, so you'll see it flaps the BGP peering. It goes down and comes right back up because it basically renegotiated as a route reflector. All right. So if we show the running config of 1, nothing changed. But if we look at the config on router 2, we can see that now we've got the route reflector client piece. So there's one more piece to this puzzle, which is the VPN v4, which will essentially extend or advertise or overlay the labels that we've defined with the label distribution protocol, LDP. It will send those labels across it's called multi-protocol BGP at that point. It'll use the VPN v4 address to get the labels across, or not the labels, I should say the route distinguishers and stuff, which we're going to get into. So let's go ahead and do that. All right. So the only peerings we're going to make for the VPN v4 are between 1 and 3. Okay. So we don't worry about 2. He's just the man in the middle. We're gonna get 1 and 3, and we're gonna peer them up through VPN v4 BGP. So do show run section BGP. We're going to introduce a new address family. Okay, so I'm going to go back one level just so you can kind of see iOS context sensitive help. So if we type address family and hit the question mark, the one we're looking for is this guy here. We're looking for VPN v4, okay? And we're just going to say unicast. So we hit enter, okay? And that drops us into the address family configuration mode. So we can see that it created the address family, but there's nothing in there, okay? All we're going to really do here is we're going to activate 10.333 in this case, okay? Oh, I'm sorry, I got to go up here. Yeah, you gotta dump. I gotta dump back to the top level. So I've got to come up here, okay, and I've got to say neighbor 10.333. I've got to tell it remote AS 7029, okay. Neighbor 10.333, and we've got to do update source loopback 0. So in this case, I'm doing a full mesh. The route reflections probably are irrelevant at this point because I'm essentially peering all three together. So It is what it is. Do show run section BGP. Alright, so we've got him. So now if we go back into here, we should be able to activate him, okay, which we can. Alright. And then the other piece to this is you have to tell it which communities to send. So neighbor 10333, we're going to send community both just to make our lives easier. Alright. So if we do show run section BGP, we can see kind of a more, this is kind of the full config at this point. So we've got the neighbors, okay, defined with the essential information, which is the AS and this update source. We've activated them in IPv4 and we've activated 3 in VPN v4. So let's go ahead and do router 3 in a similar fashion. Alright, so we're going to go under BGP. We're going to do neighbor 1 7029 and we're going to say remote AS 7029. We're going to say update source loopback 0. Alright, so things are looking good there. So now we've got BGP kind of staged and ready to go. This is from the service provider perspective, okay? So the next step we're going to be taking, and this will be a separate video, we're going to go ahead and we're going to create a virtual routing and forward instance on router 1 and router 3. We're going to create a VRF for Cisco, okay? That's our customer. So we're just going to call the VRF Cisco. We're going to define it on routers 1 and 3, and we're going to place the E00 interface in that virtual routing and forwarding instance. And what that does is it takes 00 and it puts it in its own routing table, so that way if this router had multiple other interfaces going to other customers, the idea is that they'd all be in their own VRF. That way they're all separate. They don't have any visibility into the service provider network at all. They don't have any visibility into each other's routing table. That's the whole point of a VRF, okay? So obviously in this particular example, we don't have any other customers hanging off these routers. Maybe that's something we introduce in future videos. I'm fine with that. The hard part is getting the underlying infrastructure built, which we've already done. We're doing that now. So adding customers isn't too bad. So again, maybe we'll entertain that in future videos. But for now, we're going to just work on a single customer, which is Cisco, and we're going to go ahead and define all that stuff in the next video. So stay tuned for that.